Okay, so let's have a quick read of this question. Skydiver, so the mass is 60, jumps out of airplane, 0 initial velocity. Okay, so we know that when t equals 0, v is 0, and the air resistance is proportional to the velocity, maybe model like that. There's the air resistance, gravitational pull. Write down differential equation and find the equation of the velocity skydiver in terms of time. Okay, so, and we know that mass is 60, I'm just going to put that there. Now, basically, man's jumped out here, so that's got weight mg active, and what's going against is resistance, which in this case is 0.8 v. So what we got is Newton's third law, force equals mass times acceleration, and we've got the difference in forces is going to be mg minus resistance equals mass times acceleration. Okay, m is 60 times g is 9.8. Okay, minus the resistance is going to be 0.8 v, and that's going to equal mass is 60. And at this point you should say, well, that's acceleration, and we should know that acceleration in terms of velocity and time, acceleration is dv dt. Now you know that, I know you know that because I've told you that several times, so if you've forgotten, please remember that. So I'm going to replace the a for dv dt. And don't forget, I've still got this initial condition to put in. So get your calculators out and just do 60 times 9.8. You're going to get 588 minus 0.8 v equals 60 dv dt. Now what I need is, I'm going to have to group this as one because it's a product. Bring that down, bring the t up. I will need to bring that to this side because I want all the v's on this side. So yeah, let's do it. So I'm going to end up with timesing that up and bringing that down. So switching those two over, I'm going to end up with dt equals 60 over 588 minus 0.8 v. That's got dv on this side. And now I've got it. I've got all my v's on one side, I've got all my t's on one side. Well, when they say all my t's, there is an imaginary one there, one t. All I need to do is put the integral signs in. So if I integrate this side, I'm just going to get t, and if I integrate this side, I'm going to get 60 ln of this bracket, which is going to be 588 minus 0.8 v. Then I'm going to have to divide it by the differential of this, which is going to be minus 0.8. And don't forget to plus the c. Okay, so we're okay so far. What we now can do is quickly simplify this. So that will be t equals, if you do 60 divided by minus 0.8, you're going to get minus 75. So that's going to give me minus 75 ln of 588 minus 0.8 v plus c. Now I can start putting my initial condition, which is here. So I'm going to bring in now, when t equals 0, v is going to equal 0 because the initial velocity is 0. So that's going to be 0 equals minus 75 ln of 588, take away something times 0 is 0, so that's just going to be 588. Now normally you put a modulus around there, so don't worry about that. If you have put a modulus, that's all good. And that is plus C. Now you can take that to the other side, therefore C is equal to a positive 75 ln 588. So let's draw a line here. We're almost there now. So we found the intercept, we've got this version, so I'm going to put t, because we want the velocity in terms of time. What we got is time in terms of velocity, so we need to change it around. So what we got at the moment, at present, t is equal to minus 75 ln of 588 minus 0.8 v plus 75 ln of 588. Just give me a second. I'm just going to replace this so that I've got a box here so you can see a bit clearly. Okay, so we need to make V the subject. Are we okay so far? We're good? Right, okay. So let's take this on that side and take t to the other side. So that's, yeah, let's do that first. So I'm going to take that to the other side. So I've got 75 ln bracket 588 minus 0.8 v equals 75 ln bracket 588 ln of 588, and that's going to be minus t. Now I'm going to divide everything by 75, so I'm not to undo this until I get the v out. Divide by 75, so I've got ln 588 minus 0.8 v equals, now if I divide that by 75, I just get ln of 588 minus, now that's going to be t over 75. Looks nasty, but that's the way it is. Now we need to do the inverse of ln, so that means I'm going to e both sides. When I'm e'ing both sides, I must put this in a big bracket. Okay, so that's the inverse of that. They will cancel, leaving me with 588 minus 0.8 v. Now I'm going to split this up so that when it's a minus, okay, we can still split it up and it's just to the minus power. So we've got that. They will cancel, so that, bless you, that becomes e to the, bless you again, 588 dot e to the minus t over 75. Now I did that. If you want to go for this straight away, you can do, it's not a problem. But anyway, by doing this, two things I'm going to do. I'm going to clear this so they will cancel each other, so you're left with 588 times that. So yeah, let's do that. So I got 588 minus 0.8 v equals 588 e to the power minus t over 75. Now I'm going to take that, I'm going to take the v to this side and take that to the other side. Do that because I'm running out of space. I'm going to do it in one shot. So that becomes 588 minus 588 e to the minus t over 75 equals 0.8 v, and all I need to do is divide everything by 0.8. So if I divide 588 divided by 0.8, you're going to get 735, so you end up with 735 minus 735 e to the minus t over 75 equals v, and that is how the cookie crumbles.